Hello everyone, this is Kavita Deka from Tejpur University. Uh, the title of my poster presentation is Effects of Histogram Binning on the Accuracy of Finding Flux Distribution of X-ray Binaries. So, X-ray binaries are the system consisting of a non-collapsed star and a black hole or a neutron star. And this X-ray emission from X-ray binaries exhibits strong variability at different time scales from milliseconds to years. The variation in flux across the electromagnetic spectrum over a wide range of time scales is an important characteristic of astrophysical objects powered by the compact source. So the basic concept is that the flux distribution is an important tool to understand the variability processes in this X-ray binary. And this multi-wavelength flux distribution of sources with broadbands of stochastic variability is an unique tool to understand this and prove the nature of these physical processes. And histogram fitting is one of the statistical methods which could be implemented to study the flux distribution. So the motivation of our work was to study the long-term flux distribution of a very well-known and well-observed and well-studied black hole X-ray binary Cygnus X1, and by using histogram fitting method. And so while in making histograms, the binning plays an important part because when we change the binning, automatically the data get groups into differently, and hence we observe different results. So in while performing this work, we have also observed that that with different number of bins we got different results. So here we want to report how the change in binning affects the distribution study. So to perform the study, we have used the publicly available long-term X-ray light curves from Rossi X-ray Timing Explorer, which is known as RXTE, and monitor of all sky X-ray images into different energy bands, namely as B band and C band. The energy band for RXTE band is 3 to 5 kb, and the for C band is 5 to 12 kb, and the same for Maxi B band is 4 to 10 kV, and the C band for it's 10 to 20 kV. So and also the data where the data which we have used in our work was for the time the RX data which we have used for this work were for the time period January 5, 1996 to November 5, 2011, and the Maxi data was for the time period of August 15, 2009 to October 28, 2018. So using these long-term light curves, we have made several histograms, and to fit those histograms, we have used these two probability distribution function. This one is the Gaussian and this log normal distribution function. So we have used the combination of these two combination of these two probability distribution function to fit all the histograms. Like we have used log normal plus log normal combination, or log normal plus Gaussian, and Gaussian plus Gaussian combination. So the histogram binning is was chosen such that this equal that each bin contains equal number of data points. Instead of we didn't choose that traditional way of equal bin weights. So we used this each bin contains equal number of data points condition. And we have also constrained the bin weights of the histograms so that the average error in each bin is smaller than 1.5 into bin wide. So histograms were made using the number of flux points per bin, different number of flux points per bin. For example, 50, 100, and 200, and for in each cases we have observed that we have observed that we're getting different reduced chi-square, and the best fit or the good fit was obtained with 200 number of flux points per bin. So here I have shown the best fit histogram of RxD B band on and C band. So the best fit histogram, the best fit was obtained with this combination of this log normal plus Gaussian distribution function. So here these purple points are the purple points correspond to B light curves of B and C bands. This solid green color shown is the best fitted log normal plus Gaussian probability distribution function, and this red and yellow shown red and yellow solid curves are the individual log normal and Gaussian components. So we also performed the same study for the Maxi data. Here also we chose the binning in such a way that each bin contains equal number of flux points, and continuing which we have made histograms using different number of data points, for example 50, 100, and 200, and we have observed the respective reduced chi-square. So here also I have shown the best fitted histogram with the best fitted one. So this purple points correspond to the light curves of B and C bands. This solid green color line. So here that line was also covered by this yellow one also, but the solid green color is the best fitted double log normal probability distribution function, and this blue and yellow color solid curves are for this individual log normal components. So for RxD data, we have observed that this the histograms were better fitted with this combination of log normal plus Gaussian, but in Maxi the best fitted is the best fitted histogram is obtained with double log normal probability distribution function. So from this study, we have observed that the best double distribution function fit to the histogram of RxD B and C band give a better reduced chi-square by degrees of freedom of 280.98 by 223 and 229.69 by 223 with a binning of 200 points per bin. And while the best double distribution function fit to the flux distribution of Maxi B and C band give a better reduced chi-square by DYF of 50.88 by 53 and 56.18 by 53 with a binning of 100 points per bin. So it is observed that for Cygnus X1 we have got a better reduced chi-square with the increasing of number of flux points per bin. And we also noticed that binning with equal number of points per bin has improved our study. And meanwhile, we have also constrained the bin weight of the histogram to avoid the binning of flux point with larger error bar in the same bin. So it is advisable, it is better to avoid histogram with both large and small bin weights. And in the end, I would like to conclude that the choosing of correct binning and the bin weight of the histogram plays an important role in flux distribution study. So that's all. Thank you.